0.
0. What's the number in front of C? Or the C
Negative
value?
3.
-3. All right. So I want you to use those values for A and B in this formula right here. And tell me the value of X. X equals what? You got B up top, you negate it, and then 2 times A.
Negative 0 over 4, which
Ends up being
yeah.
0. Really good, really good. Okay. All right, now to find the Y value of the vertex, you have to put X back in. Back into the original. So you have to put 0 back into this equation right here. So I'm going to grab it, snip it down here so you can see that. You've got to find f of 0. You got to put 0 in for X. What does that become?
Negative 3.
You got it. All right. Any questions on that before we move on to a similar problem?
No.
Okay, let's take a look at number 8. All right, so number 8 is the other type of quadratic that you will see. Okay. Can you tell me whether this opens up or opens down?
Opens down.
It does, and it's because of this right here. That's why it opens down. So does it have a min or does it have a max?
Max.
It has a max. Very good. Now this one is in a different type of form than the previous one. To find the vertex, it's already in what's called vertex form. X minus h squared plus k. And the vertex is h comma k. Does that look familiar to you?
Not really.
Not really. Okay. So let me give you a few examples here. All right. So let's say the equation looks like this: 2x minus 1 squared plus 3. The vertex is at 1 comma 3. But let's say it's now x plus 5 squared plus 4. The vertex is now at minus 5 comma 4. Now, how did I get these numbers on the right from the ones on the left? So the 1 comes from inside parentheses. Inside parentheses, but the 1, see how it's -1 here and it's +1 here? You see how
Yeah.
it switches signs?
Yeah.
What about the 3? Does it switch signs?
No.
No, so it's only the x value that switches signs. Now let's see if that holds true in the other one. It's +5 here, but -5 here. Does it switch signs?
The 5, yeah.
Yeah, but what about the 4?
No.
It does not. So what you have to remember, and I don't, this is again one of those, like it's an my day we made 3x5 cards. Okay, maybe I feel a lot older than you, but the internet really wasn't thing yet, and we didn't have Quizlet, we didn't have other stuff. Whatever you want to use to remember this is really important, and there's probably already one made up for you for your class.
Yeah, probably.
But you have to remember that the vertex is you'd switch the number on the inside, keep the number on the outside. And I leave it to you to sort of figure that out. So now let's go back and look at your problem here. I want you to figure out the vertex. What number do I write in the X position?
0.
Okay, we just did. We did two
Right.
examples, Tristan. Help me out here. Like I'm giving you a problem just like this. So you either
-5.
say, hey, I don't understand at all, or give me the right answer. Help me out here.
-5.
What number's in parentheses here?
-4.
Do we keep it or switch the signs?
Switch the signs.
Okay, so what number goes here in the first
4.
position? 4. What about the next one?
1.
You got it. Very good. Okay. So that's everything I have to say on quadratics. We will now move to some inequality stuff. And like I said, like it's just we can't do everything, so we got to do
Yeah.
some of each. All right. I don't like this problem, but are you turning this in for an assignment, or just this is just to review?
Nah, I'm not turning any of this in.
You're not turning in. Okay, they're very good. That helps out here. So let's say it's y greater than x squared plus 12x
Oh god.
plus 27. Okay. But it says to solve, we're going to solve this. Now to do this, you have to be able to factor what's written here. So to factor, you have to find two numbers that multiply to 27, but add to positive 12. Multiply to 27, but add to 12. Take a moment here and see if you come up with that.
9 and 3.
9 and 3. So you write x plus 9, x plus 3 here.
Oh, what kind
Next
of
thing,
problem is this?
it's an inequality.
Okay.
Inequality. I would it's from
It's-
section 6, chapter 6.
Just writing this one down because I remember hating these. All right.
So the next thing you have to do is set each factor equal to 0. Could you solve each of these for me, please, and tell me what you come up with?
How do I set them to 0?
So you want to like undo the plus 9.
Oh, x equals -9, and x equals -3.
Good. Okay. Now what this means, because sometimes we get so far down into the weeds of the problem, we don't even know what we're doing. It happens to, people, you and me, mom, dad, everyone's like, we got to know, like, well, why do we even do this? And the reason is we wanted to know where the original graph crosses the x-axis. Okay. Now I'm going to quickly grab a graph of this so that you can see what I'm talking about, because the word don't do it as well as just seeing it visually. I'm a visual person. Let me snip these in. Almost there. All right, so here is the graph of that original function. And do you notice that it crosses the x-axis at -9 and -3?
Yeah.
Okay. And that's what I wrote down here on this number line. I wrote, okay, -9 and -3, where's where it crosses the x-axis. We are interested where the graph is when it says y greater than means above the x-axis. Y less than means below the x-axis. So in your problem, you want to know, where is this graph? Where is this green graph above the x-axis? And you can just say visually, it's here on the left, here on the right.
Yeah.
And so think about those 2 points. It's, and I'm gonna highlight color code here. It's yellow corresponds to that yellow, and it's that red corresponds to that red there. And that's your answer. All right, let's try one more of these just to see if get some full clarity on it. So let's say it's y less than or equal to x squared minus 4x minus 5. All right, so we want to factor here this. We need 2 numbers that multiply to minus 5, but then add to minus 4.
-5 and 1.
X minus 5, x plus 1. Good. Now you still set these equal to 0.
X equals 5 and x equals -1.
Okay. Now those go on a number line. Like that. Now, it helps to have the original graph. It helps to have the original graph, but really all you got to know is whether it opens up or down. Does this graph up here open up or down? And it has to do with this leading coefficient here.
Up.
It opens up. So I'm going to draw a graph of this. This graph is correct because it has to hit the x-axis at -1 and 5 because we said those are the zeros. All right, and now what are we interested in? What does this inequality here mean? Does this mean above or below the axis when it's written this way?
Below.
Yeah, it means below. And again, this is like one of those things, like if you're not sure, you got to find a way to write it down, remember it for your test, because it's easy to go the wrong direction. And there you have it. Any questions on that?
No.
I don't see much writing down going on here.
Okay. So that's a little bit on quadratics and inequalities. Let's look at a few more zeros. Let's look at this problem here, 18. Again, we can't go through everything. I wish we could. We would need, the whole day, but we could do some here. All right, here you go. Here is a function, and let's just say it wanted the zeros. Okay, and the zeros, it really means to factor. Okay, factor. We've been doing that for a while. You had some experience last year before factoring. The very first type of factoring you should always do is what's called the greatest common factor. All right, so when you look at this right here, when you look at x cubed minus x squared minus 2x, is there a number or a letter that goes into both?
Um,
Or all three, I guess, all of them.
X.
X. So you can actually factor an X out of each, and you're essentially dividing by X. Will you tell me what goes in parentheses here?
X squared.
Good.
Minus X. Minus.
So the X's cancel. They're the same at the top and the bottom.
2, then -2.
Yes, really good. Now from here, you can factor what's on the inside. You got to find two numbers that multiply to the last, but add to the middle. Is that okay? Multiplies to the last, but adds to the middle.
Uh, uh, I don't get it.
Okay, what did we do here in this one? How did you come up with x minus 5, x plus 1?
Okay. What's the number we have? Well, find what it multiplies and adds to -4, but
So this one is -2, and if you need to, you write a -1 there.
then wait, -2 and 1.
So x minus 2, x plus 1. You bring the x down. Now you'd set all three of these equal to 0. X equals 0. X minus 2 equals 0. X plus 1 equals 0. Could you solve those for me, please?
Yeah. Yeah. X equals 0, x equals 2, and x equals -1.
Very good. Okay. All right. So just let me just throw one other thing at you here. Let's just say it's x plus 1, 2x minus 3, and x minus 2 equals 0. Could you solve these? Solve this for me, please, because you said each of those factors equal to 0.
Okay. Uh, -1. Um, um, 1.5, or wait,
Yep, that works. 1.5. Yep, I'll take it. How about the last one there?
2.
You got it. Very good. All right, so let's transition here. We're gonna get a little coverage on everything. We're not gonna fully cover everything, but you can always look back at your notes from previous lessons. Has your teacher hinted at what might be on the final? Like any sort of idea, like, hey, this is gonna be on there for sure?
I mean, not really. I mean, in class, she kind of just like goes over the chapters, I guess, like briefly, and just moves on to the next one, like the next day or whatever.
The thing that you're always looking for is like, any hints, right? Anything that you think, well, this is really important. They're trying so hard to say like, hey, this is going to be on there. All right. So you got a little bit of class time between now and your final. Maybe you'll notice something. All right. So we're going to talk about dividing polynomials. All right. So here's a problem that I'll throw in front of you. X to the 4th minus 2x squared minus x minus 10 divided by x plus 2. So there are actually two ways to solve this problem. One is long division, and a second is synthetic division. This is a great question to ask your instructors and say, hey, I was working on some problems over the weekend, and I want to know whether it's whether it's gonna be long division or synthetic division on the final. And maybe they'll give you a hint. You know, that's always good to know.
I'm pretty sure it's definitely going to be synthetic division.
Okay, and that's what I was gonna say. We're probably gonna get this on there.
Yeah.
So the way you do synthetic division is you first set this x plus 2 equal to 0. Can you tell me what that becomes?
-2.
So -2, and that goes in the box. Okay, the numbers that go in parentheses here, or come from what's in parentheses. It's the coefficients. What's the number in front of x to the 4th?
-2.
In front of x to the 4th. To the left of. In front always means to the left in math.
Oh, 1.
1. And then is there, and this is kind of a trick question, is there an x cubed here? Like, do you see one?
No.
No, and the reason you don't is because there's a 0 in front, and 0 times anything is 0.
0.
So here's your 0 for that. -2 for the x squared. -1 for the x. And then -10. So just kind of look this over. 1x to the 4th, 0x cubed, -2 for the x squared, -1 for the x, -10 for the 10. And the -2 in the box came from this right here. Any
Okay.
questions on that?
No.
Okay, so now the real fun begins. A lot of students actually like synthetic division because it's not really numerically compute intensive. You just bring down the first number, 1, just bring it straight down.
Yeah.
Then you take the 1 and multiply by -2. That's -2. Then you always add vertically. Like when you bring it down, you're really adding it to 0. That's why you just bring it down. -2. Then you multiply -2 times -2, which is 4. Add those together. That's 2. Multiply 2 times -2 is -2. So again, make sure you understand the pattern of where the numbers are coming from. You're adding in here. That's -3. And then you take the -3 and multiply by the number in the box. That's 6. And you add together here. And there's your answer. So this right here, this last number is your remainder.
Okay.
Okay. One of the things we're not really seeing is how they want you to write your answer, but it's typically like this, and all of this refers to your quotient. So they want it to be your quotient plus your remainder over your divisor. And it looks like a lot. It's like, how am I going to remember all this? The remainder is this last number, another thing to write down. The quotient's everything left over. What's the divisor? Well, it's what you started with. This right here is your divisor, the x plus 2.
Okay.
Okay, so you actually have everything. Now, if you recall, the 1 up here was for the 1x to the 4th, 0x cubed minus 2x squared minus x, so on. When you divide, these all go down by 1. So it's no longer x to the 4th like it was up here. The 1 down here now is x to the 3rd. So it's 1x cubed minus 2x squared plus 2x minus 3 plus your remainder, which is -4, over your divisor, which is x plus 2.
Okay.
So let's review, because I'm gonna have you do one similar, not as difficult, but I want you to see if you can kind of piece this together. So we started out by setting the divisor equal to 0. The thing that you're dividing by, that's the divisor. You set it equal to 0. Like, okay, you can do that. No big deal. Absolutely doable. The next thing is you put that number, that -2, in the box. Then you put all the coefficients and whatever it's starting with, like this was x to the 4th, so you start with that one. And in a new problem, it might just be the x squared, so you start with that coefficient, right? All the coefficients here. Then we made this horizontal line, and then we bring the number down. Bring it down, we're adding basically, multiply, put the new number, add, multiply, put the new number, add, and so on. Any questions on that? Anything you feel like you don't understand before I put a problem in front of you that's less sophisticated, but something you can do?
No, I think I can
Okay.
do it.
All right. So what I'm asking you to do now is just to set up on your paper, just set up. You don't have to do it all. Just set up the division. Figure out what goes in the box and the coefficients.
Um, 3. 6. 7, 6. So I have 3, 1, 0, -7, and 6.
-6. Why is it -6?
I mean, I thought this was the, yeah.
Yeah, you said 6. I don't know. Maybe
Oh,
you meant
no.
-6. I don't know. I go off what I hear because
Yeah,
I can't see
sorry,
your
I mean,
paper.
I misread it.
Okay. All right. So here's what I want you to do next. This is correct. I want you to figure out the numbers that go down here. Let me know when you're done, and I will do the same thing. I will put them. But go ahead and work that out, please.
Is it x squared plus 3x plus 2?
Like this.
Yeah.
Okay, so you bring the 1 down, that's good. 1 times 3 is 3, adds 3, then you get a 9, very good, which is 2. 2 times 3 is 6 with a remainder of 0, very good. Any questions on that before we move on to something new?
No.
Okay. All right, let's see, let's just get back to this. So we did it, polynomial equations. Let's see if there's any other things here. Oh boy, I mean, there's so much here. It's just like, what do you do? There's everything. Let's look at one more factoring that we have not done yet. Okay, so this one we're going to factor, and then after this we'll move on to a new chapter. Factor here. You're pretty good with your factoring, but this is a different type. It's called grouping. So you're looking at these first two right here. Okay, and you're deciding, well, what is common between them? What goes into both?
X.
X squared, because
Yeah.
because the smaller exponent is x squared. Now tell me what goes in parentheses.
X plus 1.
So whatever goes in here, like obviously I'm looking for a different answer. Whatever goes in here, when you multiply and you have to get back to this previous line. So somehow you got to get a 6. Now I agree with the x, but how are you going to get back to a 6? So a hint here, I'll just drop a hint in. Sometimes it's you're dividing both of these by the x squared.
Uh, 3.
Your
Negative
x squared
3.
divided by x squared, they cancel. What's left over?
Negative 6.
-6. Yeah. Okay. Now, this one is, now that I realize what we're doing here, this one is not a good example because it actually does not work with this other one. But so I'm not sure why they wanted you to do this. Okay. So we're gonna move on. Unfortunately, this one doesn't work out. I was looking ahead. Maybe this other one does. Nope. Okay. Transitioning to chapter 7. All right, so let's look at something totally different. Resetting, kind of like if you didn't like the last stuff, maybe you like this. So this one says to simplify the root. Okay, and this is kind of another thing you might put on the note card. When you have a root of a over b, it's the square root of a over the square root of b. So this case, it's the square root of 4 over the square root of 81. Do you remember
Okay.
either of those values?
2 and 9.
2 and 9, perfect. So those are the nice ones. You might even like the word friendly. They're friendly, okay? But
Yeah.
where it goes from here is, well, maybe they're not all friendly, okay? And we will see such problems. Like, let's say it's the square root of 27. And we're just asked to reduce something like this. Okay. Do you remember how to write this or how to factor it?
Yeah, the 2 lines, like 3 and 9,
Yes,
And
then-
3.
yeah. So this becomes 3 square root 3. Okay. So now the real problem we're gonna do here is the square root of 27 x to the 6th. So this is really the square root of 27 times the square root of x to the 6th. And you just did the part on the left. Okay. How do you do the part on the right?
Uh, um, divide.
So the square root of x really means x to the 1/2. So this x to the 6th is really to the 1/2 power.
Okay.
So what is 6 times 1/2? 6.
3 over 2.
6 over 2. So you multiply the
Right.
top, you multiply the bottoms.
3 over 1.
Okay, so just 3. So notice you're taking half
3.
of the variable. Yeah. Okay. So
So it would be 3 square root of 3 x and
x
x
to the
cubed.
there. Yeah. And then you have to kind of replace, you have to say, okay, I'm going to reorganize everything where there's stuff outside the root and there's stuff inside the root. So in your problem, it's 3x cubed square root of 3.
Okay.
All right, so let me have you try one here. Let's have you try the square root of 45 x to the 8. Why don't you try this one for us, please? If you need me to, I can scroll up and look at the other one.
Oh yeah, can I see the top one real quick?
Sure, sure.
All right. I was can you go back down now?
Yep.
Should be 3 square root of 5 and x to the 4th power.
So it's 3x to the 4th square root of 5 like this.
Oh, okay. All right.
Okay. So now the next question here is well, what to do when it's x to an odd power? Okay, like let's say it's the square root of 36 x to the 9th. Okay, and the answer is that you make the x to the 9th into the next lowest even power. So it's x to the 8th times x to the 1. So this is really the square root of 36 x to the 8th x to the 1, like that.
Mhm.
Okay, and then you apply the same strategy. You're like, okay, square root of 36, square root of x to the 8th, square root of x. Now this one on the right here, you can't do anything with. It's totally,
Yeah.
but these two you can.
Would it be 6x to the 4th power?
6x to the 4th power on the outside, square root of x on the inside.
Okay.
I'm gonna give you one to try, so I hope you can get that down.
Is there any way I can use the bathroom real quick?
Sure, we only have a little bit of time, so yeah, go ahead and get there, get back as soon as you can.
All right, I'm back. If you're talking, I can't hear you.
Yeah, sorry. So we're gonna do one more example, or maybe two. We're gonna do cube roots now. Cube root of 8, x to the 9th, y to the 11th. And it's really similar to what we've been doing. It's the cube root of 8, the cube root of x to the 9th, the cube root of y to the 11th. Now the cube root of 8 is 2. 2 times 2 times 2 is 8. The x to the 9th becomes x cubed because you divide by 3. Now the question is what to do over here with the y to the 11th. Well, it's kind of like what we did with the odd powers is you have to go down. You go down to the next multiple of 3. So it's the cube root of y to the 9th times y squared, because 9 is divisible by 3. So this is really the cube root of y to the 9th times the cube root of y squared. So the cube root of y to the 9th is y cubed. And you bring this other stuff down with it. And you have some cube root of y squareds left over.
Okay.
All right. So we did not get through section chapter 9, 10, 11. That is the more recent stuff. So maybe that will be familiar.
I mean,
Fortunately,
yeah,
we do have.
yeah, it should be